So hey everyone, we are going to model and simulate upthrust bearing. Basically, upthrust bearing is used to uplift and heavy machinery and to rotate it to reduce friction losses. First, we will model it, then meshing, and then simulate. We were all doing this in our ANSYS software. First, draw a circle of length of diameter 200 mm. You just simply click on circle icon. Now pull it 0.5 mm. You think there is a thickness is created. Now again move on to sketch mode. For sketch mode, just click on sketch mode and you will come to the sketch mode. Now again take a circle of diameter 112 mm. Now again pull it. There you can see the our drawing is on the backward plane. Just pull it 35 mm or 12 mm and it's created. Again come to sketch mode and draw a circle of 12 mm and pull it 35 mm. Here our model is ready on which we are going to simulate. This is the upthrust bearing. Here we applied an pump pressure with the pump and this pressure outlet distributed the pressure. We come into our meshing window through workbench. Now you can see our model is imported here. Now we are going to provide name selection. Just click on the surface. Here you can take moving wall, and here we have to provide inlet at this surface, and I will rename it as inlet. Now we are going to provide static wall. Previously we have provided moving wall. This is our static wall. Now we have to select this 0.5 thickness face for our outlet. Here you can see it is ready. This is our inlet. This is our static wall. This is our outlet. And now we are going to generate our mesh. Take mesh size of 1 mm. In the drop down menu you can see here element size is default 14.3 mm. You have to edit it for 1 mm. And now right click on mesh and generate mesh. In the bottom you are seeing it is meshing, so don't do anything while it is meshing because it using your system. Here we can see our meshing is ready. We have provided a fine mesh for a precise analysis. Now we are in our fluent window. You get into it through workbench. Here you can see our outlet is showing, inlet is showing, and static wall and moving wall. I click on gravity and put the value 9.8 minus 9.8, and here I'm writing a code: define model viscous turbulence expert. There is no space, there is hyphen. Turb hyphen non Newtonian. We are doing this for our option is enabled, that is non-Newtonian fluid in our material section. Now viscous omega fluid, and here you can see I already write it as bearing fluid. You have to there is a window is open, actually it is not coming in screen recording. Bearing fluid, you a window is open. Here you can edit. I will put an image for this. Now you have to edit boundary conditions as inlet pressure type, because we are providing pressure, so we have to choose inlet as pressure, and we have to put the value of 5 e to the power 6 and 5 megapascal. Now we have to initialization. We have to do hybrid initialization. Click on hybrid and just click on initialize button. Run calculation. Provide number of iterations 140 and just calculate it. It will take a lot of time. And here you can see a graph is generated during result is generating. It will take a lot of time, so just make sure you are not using any other software while using ANSYS student. Don't do anything until it's completed 100%. Just leave it. After 140 iterations, our result is calculated. Now we will click on contours and we will select all body, and here you can see our pressure distribution. So where is the pressure maximum? Where we applied through this pump at the inlet. At the some distance, it will the pressure is high and it is decreases exponentially. Here you can see the blue is showing the minimum pressure and the red is showing maximum pressure. Now we are plotting a graph. First we will see path lines of this. how pressure is diffusing throughout the body. It will take time to process. Here you can see path line of the pressure distribution throughout the body. Uh, at the center you can see there is a maximum pressure, and the boundaries you can see the pressure is decreases. I will show a graph later on that will show how pressure decreases. Here you can see the pressure lines, path lines of pressure. Now we will plot a graph, xy graph. uh, Here you can see at the center our pressure is maximum, and at the two curves it decreases